Hurtling towards Earth at an astonishing speed, Apophis stands as a celestial harbinger of potential doom. But how close is too close for comfort? Are we prepared to face the challenges posed by such a formidable asteroid? Stay tuned as we delve deeper into the mysteries of Apophis and the unprecedented efforts to understand it. Apophis, identified as one of the most potentially threatening asteroids ever found, is approaching our planet. By 2029, it will come within a mere 32,000 kilometers, or roughly 19,900 miles of Earth, passing beneath the orbits of geostationary satellites and shining as brightly as one itself. This occurrence is a rare event, visible to billions of naked-eye observers worldwide, happening only once every few millennia. Adding to the excitement, NASA has already launched a mission to closely study Apophis. However, one may question why we need a spacecraft to investigate this asteroid when ground-based observations are possible, or why we're dedicating resources to examine a celestial object once labeled the most perilous asteroid. Most significantly, does this situation warrant concern? Apophis, with its peanut-like shape, was initially detected in 2004, located approximately 170 million kilometers away from Earth. Initially designated as 2004 MN4, this 340-meter-wide rock did not appear particularly significant. However, subsequent analysis revealed a 1 in 37 chance of it colliding with Earth in 2029, sparking widespread attention. This 1 in 37 probability represented the highest ever calculated for a notable asteroid impact in recorded history. This marked the moment when the asteroid acquired the name Apophis, named after the Egyptian god of destruction, and gained its reputation as the most dangerous asteroid ever discovered. In March 2021, Apophis executed a distant flyby of Earth, providing astronomers with a unique opportunity to employ advanced radar observations for precision in refining its orbit around the Sun. Thankfully, the updated analysis conclusively ruled out any significant Earth impact events for the next century. However, an essential factor that cannot be dismissed is the Yarkovsky effect, a consequence of the interaction between the asteroid and solar radiation. This effect arises as sunlight heats the rotating asteroid's day side, while the night side cools down and releases heat as it turns. This process generates a slight thrust, which can gradually alter the asteroid's trajectory. Modeling the Yarkovsky effect is a complex undertaking, yet it holds significant implications for determining the future paths of asteroids. Because the precise impact of the Yarkovsky effect on Apophis orbit remains uncertain, our understanding of its trajectory as it approaches Earth in the coming years is limited. Consequently, scientists must consider a range of potential trajectories, contingent on the strength of the Yarkovsky effect's influence on Apophis. Some of these trajectories intersect with regions of space referred to as gravitational keyholes. Should Apophis pass through a keyhole, Earth's gravitational pull could subtly modify its path, potentially leading to an impact in a subsequent orbit. Since its discovery, astronomers have been closely monitoring Apophis' trajectory. Ground-based observations and radar measurements have revealed a gradual departure from a purely gravitational orbit. Should this deviation persist, the possibility of an impact event in 2068 cannot be entirely dismissed. In other words, there remains a slight chance that this substantial asteroid could collide with our planet within the next 50 years. The Yarkovsky effect's intensity is influenced by various factors, including changes in an object's temperature due to radiation exposure, asteroid composition, and the effects of stellar wind, among others. Therefore, arriving at definitive conclusions necessitates close and repeated observations. This is where NASA's OSIRIS-APEX mission assumes a critical role, filling crucial information gaps. The OSIRIS-APEX spacecraft shares its origin with the mission launched in 2016, initially known as OSIRIS-REx, which had the primary goal of collecting samples from the asteroid Bennu. On October 20, 2020, it achieved a successful touchdown on the surface of Bennu, collected a sample, and subsequently returned it to Earth on September 24, 2023. During this process, the spacecraft released a capsule containing fragments from Bennu into Earth's atmosphere, and this capsule descended safely using a parachute, landing in Utah. The sample retrieved from Bennu stands as the largest asteroid sample ever brought back to Earth. However, the journey for the spacecraft was far from over. Shortly after releasing the capsule containing the Bennu sample, approximately 20 minutes later, the spacecraft initiated a new mission, now referred to as Osiris Apex. Currently, Osiris Apex is on its way to rendezvous with Apophis. Specifically, the acronym Osiris Apex stands for Origins, Spectral Interpretation, Resource Identification, and Security Apophis Explorer. Just 1 hour after Apophis completes its close approach to Earth on April 13, 2029, Osiris Apex will utilize Earth's gravity to establish an orbit around the asteroid. During the next 18 months, it will conduct an extensive study of Apophis, gathering valuable data. Unlike its mission with Bennu, Osiris Apex will not be able to collect a sample from Apophis. Nevertheless, it will approach the surface of the asteroid and use its thrusters to execute a maneuver designed to expose Apophis' subsurface, providing researchers with insights into its physical and chemical composition. Over the course of 1.5 years, Osiris Apex will conduct thorough mapping of the asteroid's surface. This will enable mission scientists to examine any significant changes resulting from Apophis' brief interaction with Earth's gravitational influence. Although tidal forces are relatively small, they can still trigger minor landslides and uncover fresh material on the asteroid's surface for further study. Additionally, the spacecraft will precisely calculate the asteroid's orbital motion, down to a meter-scale accuracy. This heightened precision will empower researchers to make accurate predictions about Apophis' future trajectory. Presently, predictions extend only until 2116, but Osiris Apex's measurements are expected to significantly extend this forecast horizon. However, it's important to note that Osiris Apex is not the sole spacecraft with plans to visit Apophis. Several missions are also targeting this asteroid. Among these missions, a South Korean team has proposed launching a spacecraft in 2027, set to arrive at Apophis in January 2029, just before Apophis' close approach to Earth. The primary objective of this mission is to gain a more detailed understanding of the structural changes that Apophis undergoes during its near encounter with Earth. Furthermore, there are plans for missions involving smaller spacecraft, such as Apophis Pathfinder, scheduled for launch in 2025 to 2026. This particular spacecraft will perform the very first close flyby of Apophis, reaching the asteroid within approximately 1 year of its launch. Additionally, earlier this year, NASA officials put forth a proposal at the 8th Planetary Defense Conference, suggesting the dispatch of a swarm of tiny spacecraft to investigate Apophis. A comprehensive study of Apophis will undoubtedly pave the way for a better understanding of various hazardous asteroids that may pose a threat to our vicinity. These missions represent a significant leap forward in advancing our knowledge of Apophis behavior, ultimately guiding us in the development of effective defense strategies against potential asteroid impacts. Apophis embodies more than just an astronomical curiosity. It serves as a pivotal focal point in our ongoing quest to comprehend and prepare for cosmic hazards. The collective efforts of NASA's Osiris Apex mission, along with international contributions like the South Korean project and the Apophis Pathfinder, underscore a global commitment to planetary defense. These endeavors not only aim to unravel the intricacies of Apophis, but also set the stage for advanced strategies to safeguard Earth against potential asteroid impacts in the future. As we stand on the brink of these groundbreaking explorations, the journey of Apophis from an ominous threat to a beacon of scientific opportunity illuminates the remarkable progress in space exploration and our ever-growing capability to protect our planet. How do you think the study of asteroids like Apophis will impact our future space exploration and planetary defense strategies? Feel free to express your thoughts and viewpoints. And be sure to join the RlD Discovery community by hitting that subscribe button to stay up to date with lunar revelations and the forthcoming frontier of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up.